Hello, in this video we are gonna do physics one shot revision, and it's pretty much similar to the maths one shot which we did yesterday. So in this video I'm not gonna cover the whole physics in very much detail, but it'll be more sort of formula sheets and some of the previous year questions discussion sort of video. So without delay, uh, I will try to keep this as short as possible. So without delay, let's dive in. So I would like to start with the very basic unit, that is units and dimensions. So in units and dimensions, it's pretty much basics because it's gonna help you in NAT section particularly, because in NAT sections you tend you have to convert your final formulas and for your final values to required units. So you must pay attention to this particular thing. So for length we use meter, and I would like to start with the unit conversion thing. So there are few prefixes that you should remember. Let's say for centi, you remember this, and I'm writing those only which are like way commonly used. For micro, remember this. You have to remember it like this only, and then I will tell you a trick to convert any unit to another unit very easily. You just have to remember a simple line. Nano, it's capital M, okay. Oh, sorry, I read micro is -6. I was about to write milli. Milli is 10 to the power -3. Okay, so yeah, let's say if I have to convert this 1 meter square to centimeter square, how I'm gonna do, how I'm gonna go about it. So you just have to remember a simple rule, that is to remove, multiply, and to put, divide. You just remember this trick. This is way more useful. So let's go about this. So I have to convert 1 meter square to centimeter square. How I'll do it? So since it's meter here, I have to put a C here, that is centimeter C. So it's like to put, I have to divide. Okay. Huh. So what you learned for centi? Centi was 10 to the power -2, right? So it's 1 meter. I have to put C here. It means I have to divide this. That is 10 to the power -2. But since it's a square, so I will square it. Great. So it is 10 to the power -4 means 10 to the power 4. So there are 1 meter square is equal to 10 to the power 4 centimeter square. So let me tell you quickly one more example. So let's say if you have to convert 1 millimole to micromole. Micromolar. How you are going to go about it? So this is micro. For micro, the thing was 10 to the power -6, and for milli it is 10 to the power -3. So first I will remove this. I have to remove this. So for removal, the formula is to remove, multiply. So I have to multiply it with 10 to the power -3 because milli ke liye it's 10 to the power -3. And I have to put micro. For micro it's this. So to put, divide. So I have to put this. Great. So it's minus here, it will be plus minus 3 plus 6, that is 10 to the power 3. So in 1 millimolar, there are 10 to the power 3 means 1000 micromolar. I hope you understand this thing. Just practice a bit, you will be able to follow it in a very easy way. Okay, let's move on to the other thing. There are very basic formulas. I hope you already know these, but since I'm like doing a quick revision of the things, so I am gonna write it. Okay, for velocity, it's displacement upon time, and for acceleration, it's change in velocity. It's means final velocity minus initial velocity upon time. And for force, it's mass into acceleration. So in this way, mass ka unit is kilogram, and acceleration is, velocity is meter second, meter per second, and velocity ka meter per second, and time ka second. So one it's plus here, so it will be minus, that is ms minus 2. In the same way, mass ke liye it's kilogram, and for acceleration it is ms minus 2, right? Force का formula है, that is mass into acceleration. And similarly for pressure is force upon area. So if I have to find the unit for pressure, that will be kilogram. Force का formula, force का unit, that is kilogram meter per second square. This is area. Area is length into width, so that will be meter square. 1 meter cancel, then it is be kilogram meter inverse per second square, and this is also given a shorter term, that is Pascal. Okay, then the next formula is work done. So work done is force into displacement. So these force is also a vector, displacement is also a vector, but they are like, it is not cross, it's dot product. So dot product of these two vectors is a scalar. So work done is a scalar quantity. And there is one more formula, that is stress. Stress is also force upon area. If you will remember these small formulas now, then even if you won't know what is the actual concept that you have to apply in a particular numerical type question, still you will be somehow able to figure it out. And there is one more formula for pressure. Pressure is equal to rho g h, where g is acceleration due to gravity and h is pretty much the height or thickness, whatever you want to say it, and this is the density. So there was a question in 2023 paper that came from this formula, rho g h. You just have to like identify which are the quantities given in the NAT question, and you immediately have to remember which formula, like say if in the question you can see pressure, density, all these things, and you know that there is a formula that connects these density and pressure, then uh, simply you just have to put down the values in the formula and you are good to go. So it's always good to remember all these formulas. And this formula sheet I have already updated in the like in my Telegram group. You can go and just have a look on these formulas. And if you just write these formulas 2 times now, you will tend to remember these, because these are very basic formulas. Okay, let's move on to the another concept, that is the absolute error and relative errors. So let me first tell you what error is in very brief, I would say. So let's say there is a true value, means let's say there is a pen and company says this pen is, let's say, like let's say 10 centimeter or something. I'm randomly choosing a pen, which is of 10 centimeter, and you brought that pen and you just measured it, and one of your friend measured it came out to be 9.8 centimeter, and some other person measured it and it came out to be 9. Somebody else measured it was 10.1 centimeter, right? So there is a true value and these all are observed values, right? So there is a difference between these two, like 10.1 and 1, there is a difference of 0.1, right? And 9.8 and 10 also there is a difference of 0.2, right? So these things are termed as error, and it may be due to instrumental error or a personal error or something. So how you will define relative error? Relative error will be your absolute error. This is absolute error, by the way. When you do not true value minus observed value, this is absolute error. What is relative error? Relative error is this your absolute error upon your this mean of these observations. Let's say how you calculate mean? 9 plus 9.8 plus 10.1 divided by, there are 3 observations, so you will divide it by 3. So this is relative error. So let's say if you have to calculate percentage error, percentage error is pretty much relative error into 100, as simple as this. So, and one more thing to remember is errors are always additive. Means no matter what the quantities are being added or subtracted, error will always be like, see, there is a error in this quantity, there is a little bit error, it can be more or less. If you have to plus these two quantities, it will be a plus b plus minus delta a, means error in a and error in b. And similarly, if you have to subtract them, then also the errors will be added only. So errors are always added. Okay. And say if two quantities are being multiplied, then you have to do this. Similarly, if they are being divided, then also you have to do this. Great. I hope you already know how rounding off happens. But since we are doing revision, so I'll quickly tell about it. So let's say there are, let's say it's 4.675 and I have to round it off till one decimal place. So there are 3 decimal places. I have to round it up to one decimal place. One decimal place. So how I'll go about it? See, one decimal place means I have to see this value. If this value is greater than 5, or if it is greater than 5, then I will add 1 to the previous value. Then it will become 4.7. So let's say if it were 4.64, then if I have to round it off, since it's less than 5, so I will keep it as is. But say if it is 5, if it is 5, then if the previous number is even, I will keep it as is. But if it was odd and the number is 5, then I will add 1. You got my point? Yeah. Same thing happens for this if it is 4.5 and if I have to round it to nearest integer, then also we will see this number. This is 4 less than 5 means I will write 4, but if it was 4.8 and 8, since it's greater than 5, then I will write it as 5. Okay. Okay, now let me tell you about vectors. So in vectors, I would say just remember two things. Uh, there is a vector product. So let's say if you have to like cross multiply two things. If these two are vector quantities and you have to multiply them, then a vector product will be used. So for vector product, it's like mod of A, magnitude of A into magnitude of B, then sine theta, where theta is the angle between these two vectors. Okay. So if two quantities are scalar, then what will happen? We will use scalar product. I will give two examples so that you will be able to follow it easily. Okay, so for scalar product, I have to use dot product, that is a magnitude, b magnitude, that is cos theta. Great. Okay, uh, let's move on. Let me give you an example so that you will be able to follow more easily. And as you already know, if let's say if two vectors are parallel, means their angle will be 0. If their angle is 0, so this sine theta and cos theta values will change accordingly, na? So means it sine theta is 0. Sine theta is 0 means their uh, the cross product will be 0. Okay, you got na? You got it. So if two other scalar quantities, if their dot product is 0, it means this cos theta is 0. Cos theta is 0 when theta is 90 degree. So means two vectors are perpendicular. Okay, so we got a question in 2003. Okay. So there is a vector. I'm talking about a previous year question. Okay. So A and B are two vectors such that A mod A plus B mod is equal to A minus B mod. Then the angle between them is. Now we have to tell the angle between them. Okay. So how we like find the magnitude of two things, that is a square plus b square plus 2ab cos theta is equal to a square plus b square minus 2ab cos theta. So these things will be cancelled and 4ab cos theta is equal to 0. So when this thing will be 0, this thing will be 0. This is basically a dot product, na? So as I told you in the last slide, that when dot product is 0, it means cos theta is 0. Cos theta is 0. Like either these two can be 0, but since in the question it was mentioned that A and B are not 0, so cos theta is 0. So if cos theta is 0, means theta is 90 degree. So which means the angle between vector A and B is 90 degree. Okay. Okay. So there is one more important concept, that is this average speed. So for average speed, just remember this formula: total distance upon total time. So I would like to explain it with the help of an example so that you'll be able to follow easily. Yeah. So a vehicle, okay, a vehicle travels half of the total distance L with speed v1, and the other half with speed v2, then average speed over this whole distance is. Okay. So we have to calculate the average speed. So I would like to solve this in on the next page. So it says there is a distance, total distance is L, and the person covered L by 2, that is a half distance with the speed V1, right? And the half with speed V2. Okay, that is L by 2 distance now. So what was the formula for average speed? It was total distance upon total time, right? So total distance is L. Total time, how do we calculate total time? It will be time taken to cover this half distance and time taken to cover this half distance, right? Which is T1 and T2, means T1 plus T2 is the total time. So I have to find first T1, right? So how I will go about it? Speed is equal to distance upon time, and time is equal to distance upon speed. So distance is L by 2, right? Speed was V1, right? So it's V1. So for T1 plus T2, right? So I would like to write it here. L upon, it is L by 2 V1 plus, and this was for T1. For T2, same distance upon time. Distance was L by 2 and the speed was V2. So L by 2 V2, right? Now I will just simplify it. This is 2 V1 V2 and L above, and already there is 2v1 already is there, then it is v2 plus v2 is already, so lv1, right? So if I'll take L common, L will be cancelled out and it will be 2v1 v2 upon v1 plus v2. So this will be the average speed. Okay. Okay, now let's move on to the angular motion, rotational motion. Okay, so let's say if body is moving in circular motion, and let's say the arc, this whole distance is the parameter of the circle. Okay, this is the radius and this will be the angle. Let's say if this arc length is L, if I have to calculate the angle will be arc upon radius. Okay, so what will be the displacement covered by this object moving in this circular motion? That is, you just have to remember the formula 2r sine theta by 2, and the average speed of an object moving in angular motion is 3 by 2 pi r by t, and the average velocity is equal to 2r sine theta by t. Okay, and there are few more things that you should remember. And first of all, the equations of motion. S is equal to u plus at. Is it right? Sorry, it's V is equal to u plus at. B square minus u square is equal to 2as. S is equal to ut plus half at square. So what are these? This V is the final velocity, u is the initial velocity of the object, right? A is the acceleration and t is the time taken. So maximum questions of kinematics will be solved by these three equations only. You just have to figure out where to apply which formula. Time taken by the object. And let's say if they ask you to the distance covered by object in, let's say, 4th second or let's say 6th second. So how you'll go about it? It will be distance is equal to u plus acceleration by 2n minus 1, where n is the second. If they will ask 6 seconds, then you will just put n equal to 6. Okay, let me quickly cover about the important graphs. Okay, so if there is a velocity time graph given, so let's say this is the motion of the object that is represented by this curve or line, whatever you want to say it. So the slope of this line will be equal to acceleration, and the area under this curve will be equal to displacement by object. Great. Now there are three more important results about gravity, like motion of an object under gravity, or what we call it also free fall. Let's say there is a building. I dropped a ball like downwards from the building. So this ball is nothing but under the motion of, like under the influence of acceleration due to gravity. So the motion of this ball is nothing but free fall. Okay, so for free fall there are few changes in the formulas. You just have to replace a acceleration due to gravity with, sorry, acceleration of the object with gravity, that is g. And there is a sign convention that is used for these formulas. So g is always taken as negative. Either the object is moving upwards or downwards, you just have to take it negative because it's constant. And for velocity, if the object is moving upwards, then it will be taken as positive, and if the object is moving downwards, then it's taken as negative. And similarly for the, this is displacement of the object, negative, it's taken as negative when the object is moving downwards, and it's positive when object is moving upwards. Great. So the acceleration due to gravity ka value is 9.8 meter per second square, or sometimes if it's mentioned in the question, you should take it as 10 meter per second square. And there are few important results about it. Say if a particle is, this is important, pay attention. If an object is dropped from h height, I dropped the object from h height, and it reaches the ground in t minutes or seconds, whatever you want to say, and the velocity of the object was v. How you will calculate velocity or time? So to calculate time, you will use this formula, 2h by g, and to calculate velocity, you can use this formula, 2gh. Great. So this was for the downward motion, like the object was dropped. But let's say if I am here and I am like throwing the ball upwards. So if the ball is thrown vertically upwards, for that, if you have to calculate the time, then it will be u upon g, that is the initial velocity upon gravity, and the height to which this object maximally can reach is u square upon 2g, where u is the initial velocity and g is the acceleration due to gravity. Okay, great. So there is a rain and man problem. It was all, this was asked in 2023. So rain is in this direction. So the velocity of rain is VR. We will represent it as VR. Okay. And let's say like a person is moving towards this side. Let's represent it as VG. And like let me tell you a question, and then you will be able to like appreciate this more. So I would like to explain it with the help of an example. So then you will be able to appreciate it better. Uh, oh, just let me tell you the formula first, and then I will like give you an example and tell you how to apply it. So the formula is tan inverse Vg upon Vr. Okay, so we'll always consider a man this way and man moving towards this side. We'll call it as Vg, and the rain will be Vr. Like we are considering, like as per this formula, I'm drawing the diagram. Okay, and Vg will be in this direction as well. So the umbrella, the person have to keep the umbrella this way. So the theta will be the angle between this direction north and the umbrella, right? So if I have to find this theta, then this formula should be used, Vg upon Vr. Okay. So I will just dictate the question. I won't write it because it will take more time. Rain is falling vertically downwards at a rate of 3 km per hour. So the rain is falling in this direction uh, with a rate of 3 km per hour, right? And the person is moving towards west side. This is west, this is south, north, and east, right? So the person is moving due west with 4 km per hour speed. Okay. Now we have to like a boy walking due west at 4 km per hour opens up his umbrella to protect himself from rain. At what angle should he point his umbrella? Like what should be the angle between umbrella and this north direction? So we have to find this. So we already know the formula, that is this is Vg, this is Vr. So Vg is 3, Vr is 4, right? So we will simply put it here, tan inverse Vg is 4 and this is 3, and you can keep tan this way, and you can just remember this, tan 4 by 3 is 53 degree, like sorry, tan 53 degree is 4 by 3. This is some standard angles you have to, like, not necessary to remember, but yeah, it is a standard thing. So the theta will be 53 degree, and of course it's towards west. Okay, let's move on to the next thing. Okay, let's discuss about projectile motion now. Say if I just drop an object from, like if I drop a ball this way, so the ball will go up, reaches to maximum height, and then it will start moving downwards. So I'm drawing very rough diagram, but you just have to see where things are. So ball is in this direction, u, and this is sine theta. This is the theta by the way, and this will be sine theta, and this is basically cos. Okay, you don't have to remember this. I'm just showing you this because I am giving you the formula now, so you should know. But so what is time of flight? Time of flight is the time taken by the ball to like go from this full path. So the time of flight is capital T is 2u sine theta upon g. You just have to remember this formula. And if you have to find what is the maximum height taken by the object during a projectile motion, then this formula is h is equal to u square sine square theta upon 2g. And u is the initial velocity, theta is the angle between this horizontal direction and the velocity of the object, right? G is the acceleration due to gravity. And this is the distance, which we also known as horizontal range. And if you have to calculate the horizontal range, then the formula is u square sine 2 theta upon g. Okay, great. Okay, let me tell you a question that was asked in 2021. A stationary enemy ship is docked in the sea at a distance of 1 kilometer from the coastline. So let's say this is the coastline and the ship is 1 kilometer away from the coastline. Okay. A gun located at sea level on the coastline can fire projectile at a velocity of 120 meter per second. So from there they can like projectile of like fire at with the velocity initial velocity 120 meter per second, right? What is the angle above the horizontal at which the gun must be fired to hit the ship? So we just have to find the angle, that is the theta, right? To I mean, so we know the horizontal range already, that is 1 kilometer. So now I will use this formula only. So we have to calculate the theta, I mean the angle uh, by which the fire should be done. Okay, so let me put the formulas here. The horizontal range is 1 kilometer. So since SI unit is meter, so we are gonna convert it into like meters. 1 kilometer is 1000 meters. So and U is 120 square. Sine theta, I will keep it like this only, sine theta, and I can use G as 10 because it's standard value 10. And now this is 1000 and multiply by 10, that is 10,000. 120 ka square is equal to sine 2 theta. By the way, you will be having calculator at that point, so you simply have to divide these two and then take the sine inverse. Okay, now let me see if I am leaving something. Okay, there is one few more formulas. I will quickly write those and then we'll end this video. Force is equal to mass into x. I think I have already covered these. Yeah, we have already covered this. And there is one more thing, that is momentum. So the momentum is, sorry, that was impulse. So the momentum is basically force into change in time. That is equal to impulse. This is not momentum, this is change in momentum. Not that important. Okay. I don't find more formulas. I mean, there are formulas, but it doesn't make sense to like keep on writing formulas. I have already uploaded these notes on the Telegram channel. You can just go and check if you feel like. And also there you should remember the formula for kinetic energy, that is half mv square. M is the mass, v is the velocity of the object, and also there is a relation between this momentum and the kinetic energy, that is p is momentum, by the way. Remember I have seen formula I mean questions sorry, based on this. This is 2 into mass of the object multiplied by the kinetic energy. This E is the kinetic energy. Kinetic energy is the energy possessed by a object which is moving. Okay. And also potential energy ka formula is mgh. M is the mass, g is the acceleration due to gravity, and h is the height at which the object is resting. Okay. And there is one more thing, that is coefficient of restitution. This is something related to collision. So if two bodies are colliding, then their momentum is conserved. If momentum and kinetic energy is conserved if it was a elastic collision. But if it was an inelastic collision, then the momentum was conserved but kinetic energy wasn't. So what I mean to say is, if the value of E is greater than 1, sorry, is equal to 1, then the collision was elastic, and if it was 0, then it was perfectly inelastic collision, and if it was in between, then it was neither elastic nor inelastic. It was somewhere in between these two. And the formula to find this E is V2 minus V1 upon U1 minus U2, which means when initial velocity of these objects and the final velocities of these objects. Okay. I can see much questions from these topics nowadays, but still it's good to remember. Okay, I think we are done. And angular acceleration का formula is d omega by dt, where omega is the angular velocity. And the relation between linear velocity and angular velocity is just the radius. And this is a cross product. Okay, I will write one more formula for Young's modulus. And also there is a strain formula. Strain is change in configuration, change in length upon original length. Okay, it may be change in area upon original area, change in volume upon original volume. Anything is strain. Okay, so Young's modulus is basically the ratio of stress to strain, but there is a fancy way to write this, and I have seen question. Force upon area into length upon original length upon change in length. Okay, great. So yeah, we are done with this. I have uploaded these formulas. You can have a look upon these, and wishing you the luck for your exam. Goodbye. See you in the next video.